Proceeding forward, it's the 25th question that we are going to solve, and it has been brought from the topic Ydse, interference, wave optics. Yes, so in a Ydse, the path difference at a certain point on the screen between two interfering waves is 1/8 of the wavelength. All of us know when it comes to interference, the first and foremost thing we see is the path difference and subsequently the phase difference. The ratio of the intensity at this point to that at the center of a bright fringe is close to. Since nothing has been said about the relative intensity of the two interfering waves, we assume both to be of equal intensity. So that's on a simple faith we can go. Now here see, in the first case, the path difference, if you see, is lambda by 8. So consequently, the phase difference is going to be pi by 4 by the simple conversion between the path difference and the phase difference. Now, interestingly, whenever I have two interfering waves of same intensity, I net, I'll be getting as 4 I naught cos square phi by 2. Okay, so that's the net intensity at any given point when the two interfering waves have same intensity, and that's the case now. Now all I need to do is that, see, I require to calculate the ratio of intensity at this point to that at the center. So here the required thing is I need to calculate the ratio, but yes, we need to move a bit carefully. So required thing is 4 I naught cos square pi by 8, because at a given point where the path difference is lambda by 8, this will reduce to this given point. And the next is the case where the intensity is maximum. So quite obviously this one is going to be 1 and that will be 4 I naught. So this is the required thing. A bit of trigonometric effort, not at all difficult, a very simple thing, your regular bread and butter. You do that, you come up with option number 4 as the correct option for 25th question. Now let's move to question number 26, shall we? Now it's time to go to question number 26. And question number 26, as it's clear, it has been picked from the topic of satellite. So it's something like this, see. A satellite is revolving in a circular orbit at a height h from the Earth's surface, and this condition has been given. Small h, very, very much less than the radius of the Earth. And now what is the question? Yes, one more advantage. When the height is very close, the atmosphere is going to create its effect, primarily the viscous drag, but that has to be neglected. So that's another bonanza we get. And now the question is, we need to calculate the minimum increase in speed so that the satellite could escape from the gravitational field. Minimum is the word. In other words, the orbiting satellite should acquire escape speed, because escape speed is that minimum speed required so that the particle would escape the gravitational pull of the Earth, right? So that's the main thing that we need to do. So here, let's try to say, initially, orbital velocity is of course root gm. Actually, it's divided by the radius of the satellite, but this time the radius of the satellite can be approximated to radius of Earth, because the satellite is very close to the Earth, which has been given. And that thing now says it to be under root of g times r. Now, this is the first data, the orbital speed of the satellite when it is very close to the surface of Earth. The second thing is that, let's just see how much is the escape speed. The escape speed is root of 2gr. That's the escape speed. That's the speed which is required. Now here you can very easily understand that the increase in speed would be quite obviously this, minus of this, and option number 2 would be the correct option for question number 26. Now it's time we move to 27th question. Question number 27 has been picked from semiconductor physics. And you might have marked my words what I said, that of those specific portion which are not in JEE Advanced, JEE Mains ensures that at least 2 to 3 questions are picked from those topics. Semiconductor being one of those topics which is not there in JEE Advanced, so you can always have a certain amount of expectation from this topic. And this time here it is, but this one is related to circuit, and in the given circuit the current through Zener diode is close to. Now all of us know Zener diode is a diode which is meant to operate in the reverse biasing, and when the applied potential exceeds the breakdown voltage, in that case potential difference remains constant, and that is the significance of Zener diode. But this time say the Zener diode is there whose breakdown voltage is 10 volt. So as long as the applied voltage is less than 10 volt, the Zener would not have reached the breakdown. So the question is, let's try to calculate and say this is R2, this is R2, both the value of resistances are same. So initially, let's assume that there is no current through this part. That's a smarter way. So 1500 would make 750. So let me calculate the potential difference across this. So that will be 12 into 750 divided by 750 plus 500, that's 1250. So this is the potential difference across this, all the same thing, assuming that the current through the diode is 0. And the value comes very much around close to 7 point something. And you could see the potential difference across the diode is 7 point something, and which is lesser than the Zener breakdown, the specified voltage when the diode would break down. So clearly it's a case where Zener has not reached its breakdown. It means it is in the reverse biasing before reaching the breakdown. So quite obviously the current has to be 0. Therefore, for question number 27, the correct option comes out to be option number 2. Let's move to question number 28.